to jobs. We've seen how to create a simple job, so let's dig deeper. In the next step, we are creating a failing job. So something goes wrong. So in this case, we give the command a non-zero exit status, and as you may remember, in Linux there's a return value, and if you do something that doesn't make sense, what's the return value again? Yeah.
Question mark.
Yeah. You know, I'm using that for 20 years. I can still remember it. So this one is 0 because it worked. So if you do something that doesn't work, it's question mark. Exactly. I've been programming Perl for years, so I basically should remember that. But if you're not using that from a day-to-day basis, and I haven't done programming for several years, these things, they will fade away quickly. As the more cryptic the syntax is, the quicker it slips away into darkness. So forgive me that. All right. So exit codes. You can see that there's a non-zero exit code if something went wrong. So if we just exit with a non-zero exit status, this suggests that something has failed in the container. We'll still execute the echo, so we should still see something in the logs, but let's see what happens. So you can see completion is 0. So on the job level, we haven't seen much of a helpful description. There's nothing in the events that tells us that something has failed. There is a parallelism of 1. We have 1 completion, 1 is running, 0 succeeded, and 0 failed. So the completion is set to 1, but it hasn't completed. It's a bit misleading. So there's 1 running, but nothing really worked. So I think I will try that for a number of times, but at some point it'll have to, So here we have the crash loopback off. We had 3 restarts, and so still with restarting, it didn't work. Still, that didn't say that the pod is failing, it says it's running. So we can see that the log output has been written because the echo command succeeded. So if you look back into the description of the command, so the echo command will be executed, and then as a separate shell command, exit will be invoked. And the last command basically determines the exit code that will be perceived by Kubernetes. And for this reason, you have a failing pod, although the first command succeeded. This should also give you something to think if you specify a container job. The first thing is the job can fail. If the job fails, it will recognize that using the exit code. Now, in this case, our job has not been atomic because there are two different commands to be executed. One command has been executed successfully and the other didn't. The exit code of the entire container was therefore non-zero and faulty in the perception of Kubernetes. But if the first command had modified somehow the environment, and the restart logic of Kubernetes would keep retrying, you could cause a subsequent error because something has already been modified, and your logic in your code could assume the state to be prior the execution of the first command. I mean, in this case, we executed an echo, which doesn't change the state of the pod or any dependent resources. But for example, you could also have executed a database migration, which will change the database schema of a persistent database. Or you could have changed something in a persistent volume, or something in a shared volume where there is a persistency. So in a persistent volume, also beyond container restarts. So what I'm saying is that whatever you do in the container, you either make it atomic and ideally also idempotent. So, which basically means, you know that in mathematics, it's a function that if you invoke it on itself will produce the same value. So, hope that's the right definition. Yeah, it's a function that will, if you apply it to itself, then basically creates the same value. I'm not sure about this is a precise definition, but let's go back to the job example. If you execute a certain command several times, it should always converge to the right state in the situation that you want to achieve. So let's say you delete a file. That could fail if the file doesn't exist. So maybe you should write the delete command in a way that it succeeds, because the main thing it actually wants to achieve is that the file is deleted. So the deletion of a file could fail because the file doesn't exist. So for example, if I say rm, that doesn't succeed. And if I do then that, you'll get a non-zero exit status, which will suggest your container it failed. So this simple example shows, in order to make this command idempotent, or whatever however this word is pronounced, you need to ensure that it'll succeed, as the desired outcome of the action is to have a file deleted. So if the file doesn't exist, then return a success. So you could either have a file test or parameterize the rm command respectively. I'm not sure whether this is possible, but you get the idea. Make this command in a way that you can rerun it if it's part of a larger script or part of a sequence of steps that potentially may have to be repeated because other steps have failed. All right? So takeaway here is, if you are working with init containers, it's the same thing. If you're working with jobs, write your script in a way that the automatic retry logic of Kubernetes won't create further trouble because your script doesn't work with idempotency. idempotence at this point. So ensure that this is the case, that you can rerun the commands, still create the desired outcome, and you'll be fine. Alright, the failing job. We apply it, we get a description. Yes, let's get a description again. So the job has reached the specified back-off limit. So there's obviously something wrong. So we have 0 completions. The job has failed. Interestingly, it has 0 running, 0 succeeded, 0 failed, because let's get the pods. They've been deleted. So the job has reached its specified back-off limit, which means at some point the job has to be honest to itself and say, well, I can't do the job, can't accomplish it, I'm backing off. So that's the behavior of a job if a job fails. So yeah, we have a certain number of restarts. The status of the container is crashed. Back off. Restarting failed container is a 1 you can see. Oh yeah, in the next example we do something even meaner than that. So let's create a job that doesn't fail always, but only sometimes. And let's see what happens. So that's a flaky job. So what do we do here? We simulate a failing shell command. All right. So what we basically do is we create a random number, and then either exit 0 or exit with 1. So we could, for example, copy that to the shell. And you can see that the return value of that statement changes randomly between success and failure. All right, so let's give it a try. So we're just watching it. Now it's completed. What has happened? It keeps restarting the containers a certain number of times, and so there's a retry on the level of the pod. There's so it will keep restart the pod, and at some point by chance it'll successfully complete, and at this point the job will complete too. So the takeaway here is that you have a certain resiliency, a certain, well, let's say fault tolerance in the retry behavior, or caused by the retry behavior of Kubernetes out of the box. So if your script relies on something that's rather flaky. Well, in this case, we haven't run into a problem with inconsistencies as you may experience if something like the delete file situation would happen. File doesn't exist, your script fails, although actually the file is deleted, obviously not existing. So in this case, we just have a situation where a certain task doesn't always succeed. So when could something like that happen? So let's assume you have a very HTTP request to a web service with a very short timeout, and maybe the web service is under stress, or some of the endpoints in the load balancers aren't really healthy. So you randomly get failures back, but not always, only sometimes. And then your job has a retry logic, and it'll get the result, the desired result, although the system is not in 100% healthy state. So this is nice to have, and you should have seen how the system behaves here, because you may not always want this retry behavior, because you know that if it fails, it'll fail. You may also know that your script isn't built in a way that it should do retries, so you also need to suppress this retry logic if you don't want to have it. So that's why in the tutorial we try to provoke the retry behavior so that you can observe what Kubernetes does, and that you can take further actions on controlling it.